Hi, welcome back. This is Professor Ridge, and today's lesson is on 6.8, Formulas, Applications, and Variations. Okay, so solve each formula for a specified variable. This is exercise 13 from the book. F equals L over D. Solve it for D. So idea is we want to get D by itself, and if you recall, saying if I think of this as a proportion, I can cross multiply or multiply by the LCD, same thing. You're going to get DF equals L because you're going to multiply both sides by D. And then we want to get D by itself, so now we're going to divide both sides by F. And then the D's cancel and you get F equals L over F. Wait a minute. Oops, the F's are going to cancel, so I'm going to get B. The F's are going to cancel, so I'm going to get D equals L over F. Sorry about that. And now I'm done because I got the D all by itself. Okay, so in this one I'm going to solve for R. This is number 18. And the technique here, you can't do any shortcut because it's not a proportion. We got three fractions. So I'm going to multiply everything by the LCD, which is R, little r sub 1, little r sub 2. I'm going to multiply that with everything. R sub 1, r sub 2. Here I'm going to put it in parentheses just to save some room. Okay, so the first fraction, on the left side, the big r's cancel, and I get r sub 1, r sub 2. When I distribute it, the r sub 1's cancel, so I get r sub 2. And when I distribute the second term, the r sub 2's cancel, so I get big R, r sub 2. Now, I'm solving for this R, the capital R, so I want to get it all by itself. So I get all the terms with R on one side. We've done this before. And then you factor that R out. You can write it in front or back, it doesn't matter. Oh, I messed up here. R sub 1's cancel. R sub 2, this should be R sub 1. Because R sub 2's cancel. R sub 1. Okay, so we factor out the capital R, so we get R sub 2 plus R sub 1. And then we're going to divide both sides by the parentheses. So we get R sub 2 plus R sub 1 equals capital R. And then I'm done. Alright, number 28, again we're going to solve for capital R. So on this one it's a proportion, so I'm going to cross multiply. So I'm going to get ER equals little e R plus R, capital R plus little r. I'm going to distribute the little e. Now, remember, we want to get all the capital R's on one side, so let's subtract the little er. So I got ER minus the little e capital R. Now I'm going to factor out the capital R. So it's big E minus little e. And then divide. So now you're going to get R equals ER over big E minus little e. And there we go. So number 37, we got 1 over T equals 1 over A plus 1 over B. That gives the total time T required for 2 workers to complete a job. If the workers' individual times are A and B, solve for T. So again, we want to get T by itself, so let's clear the fractions, multiply by the LCD, which is ABT. And I'm just going to go ahead and distribute it. So here the T's cancel, you get AB. a's cancel on the first term on the right side, so you get bt. B's cancel, you get at. Okay, we're solving for t, so we want all the t's together on one side, which they are. Factor it out. So a plus b, or b plus a, same thing. And then divide by the parentheses. So t equals ab over b plus a. Okay, so for direct variation, y varies directly as x translates to, so we got varies directly as x translates to y equals kx, where k is your constant of variation constant. Okay, so alternate to y varies directly as x, you could say y is directly proportional, or just proportional to. So directly proportional or proportional to. That means the same thing as y varies directly as x. Okay, so whenever you do a word problem and you read y varies directly as x, now of course y could be something else. It could be a phrase, but you immediately translate it to y equals kx. All right, let's try a couple of these. Okay, so find the variation constant and an equation of variation. In which y varies directly as x. So y varies directly as x. So that's going to get you y equals kx. So they want you to figure out what k is and then write this equation with k in. So basically, most of these problems, variation problems, have two parts to it. And we're just going to do the first part, figure out what the k is so you can write the equation that models the example or the problem you're doing. So for 44, y equals 80 and x equals 16. So what you do is you translate y varies directly as x as y equals kx. And then you plug in the values for y and x that go together. Y is 80, then x is 16. And then you solve it for k. So you're going to divide both sides by 16. So k must be 5. And now you can write the equation of variation. So the equation of variation would be y equals 5x. Okay, so that's the equation of variation. And the variation constant is 5. So there's they want both things. Figure out what k is, then you can write the equation of variation. So let's try number 48. Y equals 0.9 when x equals 0.5. So again, you start out with y equals kx because it varies directly. Put in 0.9 for your y, 0.5 for your x. Solve it for k. So we're going to divide by 0.5. So k equals 9/5. Or if you want to use decimals, 0.9 divided by 0.5 is 1.8. So now that you know what k is, you can write the equation of variation. It's y equals 1.8x. Okay, so now inverse variation is pretty similar. Y varies inversely as x translates to y equals k over x. And same thing, k is your variation constant. Y, once you know what k is and plug it in, that's going to be your equation of variation. So it's exactly the same thing, but you use y equals k over x for your equation. And the alternate form would be y is inversely proportional to. Okay, so that means same thing as y varies inversely. And then we have joint variation, which basically you do a combination of more than one variable. So y varies jointly as x, and z translates to y equals k. So it's just like direct variation, but you're going to have two variables. So y equals kxz. Okay, so that's the other form. Or you could say y varies jointly proportional to k, to x and z. All right, and then you can actually do a combination of a joint variation with inverse, or you can do a varies directly and inversely. So you can do combinations of these three. All right, so let's try a couple of word problems, see how we do. Okay, so number 56, the electric current I in amps in a current varies directly as voltage. So my suggestion is, see, all the extra words are just to describe what your variables are. But if we spell them all out, we got I varies directly as V. So the I would be like the Y and the V would be like the X. So Y equals KV is my equation of variation. It varies directly, so it's I equals K times V. Now, there's always going to be, for these word problems, there's two parts. Your first part is what we did in that exercise 44 and 48. You got to figure out K first. So see, they give you 15 volts, that's V, and the amps, which is your I, is 5. So we're going to find K, that's your first part, using V equals 15 when I equals 5. So we plug those numbers in. And we solve it for K. So we're going to divide both sides by 15. So K is 1/3. Now, part 2, we can write the equation. With K and answer the question. So the question is, so our equation of variation is I equals 1/3 V. Now we can answer the question. We want to find what is the current. Current is our volts. Find V when, current is our I. Find I when V equals 18. So we just plug in 18 for V and work that out. 1/3 of 18 is 6, so it must be 6 amps when the volt is 18. Alright, so let's try another. Okay, so number 64, it says the wavelength W of a radio wave varies inversely. So that varies inversely. So again, throw out these extra words. Let me read it once. So the wavelength W of a radio wave varies inversely as its frequency F. A wave with a frequency of 1200 kilohertz has a length of 300 meters. What is the length of a wave with a frequency of 800 kilohertz? Again, I'm going to kind of pare this down. W varies inversely. has f. So what does that translate to? W equals k over f. And again, it's going to be two parts. First part is figure out k with the given information. Find k given that the wave has a frequency of 1200, given that f equals 1200 when the length, when w is equal to 300. We could have used L for wavelength, but anyway, well, no, they told us wavelength is w, so we're fine. I just would have used L. Anyway, so I'm going to plug these numbers in to solve it for k. So multiply both sides by 1200. Cancel out the fraction. So k is 36. So 360,000. So now part 2, we can write the equation. W equals 360,000 divided by frequency. And we're going to find, so now we can answer the question. What is the length, what is W, when frequency equals 800 kilohertz? So wavelength is W, so 360,000 divided by 800. So punch that in your calculator. So 36, and I get 450. So the wavelength is 450, what were these, meters? Yeah, meters. And we can answer the question. So basically that's how all variation problems boil down. It's generally going to be two parts. First figure out what k is, like we did here. And then once you know what k is, you can write the equation for that situation and then answer the question. So I can say, well, what's W if f is 500? What's W if f is 1,000? What's f if W is 1,200? You know, so you can do it either way. You can find W or f given one of the variables. Okay, so y varies jointly as x and z, and y equals 105 when x equals 14 and z equals 5. So we're just doing the first part of the thing. Just figure out the equation, what k is. So find equation of variation. So remember, y varies jointly is like direct, but with two variables. Y varies jointly as x and z. Now we plug in all the variables to figure out what k is. So let's see, y is 105. Okay, we got to figure out x is 14, z is 5. So 14 times 5 is 70. And then we're going to divide by 70. So k is 105 divided by 70. That's 1.5. Now we can write the equation of variation, y equals 1.5 x z. And then I'll be ready to do the second part, which would be find y if x is 12 and z is 15, or find x if y is whatever and z is whatever. So now we can answer all those questions for this situation. So basically anything that behaves this way, you have to do an observed value to figure out what the k is, and once you figure that out for all the problems for that specific thing, you could use the formula y equals whatever your k value is times xz. Alright, so let's try another one. Okay, so remember I was saying that you could do combinations of all the three. So this one is basically showing you that y varies jointly as w and the square of x and inversely as z. So we're just going to do y varies jointly as w, so that's k, w, and the square of x, so that's x squared, and then inversely that's over z. So that's the equation we're going to use. Now we're going to plug in all the numbers to figure out k. So 49, w is 3, x is 7, z is 12. So 49 times 3 goes into 12. So that's 49 over 4. And then I'm going to flip it over. So k is, I'm going to times by 4 over 49. So k is 4. Okay, that's, so the equation is going to be y equals 4wx squared over z. So that's my equation of variation. So my constant of variation is 4. Equation of variation is y equals 4wx squared all over z. Alright, let's try one more word problem and then we'll call it a day. Okay, so volume V of a given mass of gas varies directly as temperature T and inversely as pressure P. If V equals 231 cubic centimeters, when T equals 300 Kelvin, and P equals 20 pounds per square centimeter, what is the volume T when, what is the volume, that's V, when T equals 320 Kelvin and P equals 16 pounds per square centimeter? So again, let's kind of simplify. Volume, that's V, varies directly as T and inversely as P. So V varies directly as T. Now that looks like an I, huh? So it's T. And inversely as pressure P. So inversely is over. So remember, there's two parts. First, figure out what K is. So we're going to figure out, we're going to plug in 231 T equals 300, P equals 20. So we're going to plug those numbers in to find K. So V equals 231 300 divided by 20, which is, I'm going to reduce this, so that's 15K equals 231 divided by 15, which reduces to 77 over 5. Okay, so now step 2, I'm going to write the equation. V equals 77 over 5 times T over P. Now I just write 77 over 5. I would just put the 77 on top, 5 on bottom, same thing. Now I've got to find V when T is 320 and P is 16. So I punch that all in my calculator and I get, well, let me do it this way. Let's see, 16 goes in 320 20 times, 5 goes in 24 times, so 77 times 4 is 308, and volume is cubic centimeters, so my answer is 308. Okay, so you can see, as far as word problems, direct variation, inverse, all these variation problems are not too bad if you can learn to kind of pair out some of the words and just get to the meat of the question. V varies directly as T, inversely as P, so I write the equation. First step, you have to be given all the variables so you can figure out K. Then you plug K back into the equation, and then you can answer the question, which is what's the volume given T is 320 and P is 16. Alright, and they all go pretty much the same way. So there you go. That concludes the lesson for 6.8. Go to my math lab, complete your exercises there, and I'll see you next time.